Tonight, as you settle into the gentle embrace of evening, I want you to imagine something extraordinary. Picture yourself not bound by the constraints of flesh and bone, not limited by the fragile atmosphere that cradles our small blue world. Instead, envision yourself as pure consciousness, capable of traversing the vast cosmic ocean at speeds that dwarf even light itself. We're about to embark on a journey so profound, so breathtaking in its scope, that it will fundamentally change how you perceive your place in this infinite universe. Where are we going, you might ask? We're traveling to a destination so distant that its light has been journeying toward us for over 2.5 million years. We're setting course for the Andromeda galaxy, that magnificent spiral of stars that hangs like a cosmic lighthouse in our northern sky. But we're not content to merely observe from afar. Tonight, we're going to pierce through the darkness between galaxies, cross the void that separates island universes, and descend into the very heart of our nearest galactic neighbor. If you find comfort in these gentle explorations of the cosmos, I'd be deeply grateful if you'd consider subscribing and sharing this journey with others who might find wonder in the infinite. The visuals are here to guide you, but feel free to close your eyes, breathe deeply, and let your imagination soar across the intergalactic depths. Also, I'd love to know where you're listening from tonight. Comment your time and location below, because there's something beautiful about contemplating distant galaxies while scattered across our own small world. Before we begin this cosmic odyssey, we must first understand the sheer audacity of what we're attempting. The Andromeda galaxy, known to astronomers as Messier 31, is not simply another collection of stars. It is a gravitational empire containing over 1 trillion stars, each potentially harboring worlds we can barely imagine. It spans roughly 220,000 light-years from edge to edge, making it nearly twice the size of our own Milky Way. To put this in perspective, if our galaxy were the size of a dinner plate, Andromeda would be a platter large enough to serve a feast for giants. But size alone doesn't capture the true majesty of our destination. Andromeda is approaching us through space at roughly 250,000 miles per hour, engaged in a cosmic dance that will culminate in a galactic collision some 4.5 billion years from now. This isn't a violent crash in any human sense, but rather a slow-motion ballet of gravitational forces that will reshape both galaxies over hundreds of millions of years. Tonight, we get to witness this magnificent spiral in all its current glory, before time and gravity weave it into something entirely new. As we prepare for departure, consider the profound irony of our situation. Every photon of light from Andromeda that reaches your eyes tonight began its journey when our ancestors were just learning to walk upright across the African savanna. The light carrying the image of distant stars left their surfaces when the first stone tools were being crafted by primitive hands. We are literally seeing into the deep past, observing ancient starlight that has traveled across an ocean of space and time to reach us in this moment. Our journey begins here, in the familiar comfort of our solar system. But we won't linger long among these well-known worlds. Earth, with all its beauty and complexity, quickly shrinks to a pale blue dot as we accelerate beyond the orbit of Neptune. The sun itself, that blazing furnace that has nurtured life on our world for billions of years, becomes merely another star among countless others as we push deeper into interstellar space. The first leg of our voyage takes us through the local group, that small cluster of galaxies bound together by invisible threads of dark matter and gravity. We pass the Magellanic Clouds, those irregular satellite galaxies that orbit our Milky Way like cosmic companions. We navigate around dozens of dwarf galaxies, each containing millions of stars yet appearing as mere smudges of light against the cosmic darkness. These are the suburbs of our galactic neighborhood, quiet residential areas in the vast city of the universe. But it's when we finally break free from the gravitational influence of our own galaxy that the true scale of our journey becomes apparent. Behind us, the Milky Way begins to reveal its magnificent spiral structure, those graceful arms of stars and dust that we can never see from our position within them. Ahead lies nothing but darkness, punctuated by the distant glow of Andromeda, still appearing as little more than a fuzzy star despite our incredible velocity. This is the void between galaxies, a realm of space so empty that if you could somehow survive here, you might see only a handful of stars scattered across the entire sky. Most of the universe is exactly like this, nearly perfect vacuum broken only by the occasional wisp of intergalactic hydrogen and the invisible scaffolding of dark matter that connects all cosmic structures. We are crossing a desert of space, following ancient pathways carved by gravity itself. As we traverse this cosmic ocean, time seems to lose all meaning. There are no familiar reference points, no planets or stars to mark our progress, only the gradual brightening of our destination ahead and the slow fading of our origin behind. This is exploration in its purest form, venturing into realms where no human foot could ever step, where no spacecraft built by earthly hands could ever travel. Gradually, imperceptibly at first, Andromeda begins to grow larger in our field of view. What started as a faint smudge of light slowly resolves into structure. We begin to make out the dark dust lanes that thread through the galaxy's spiral arms, the bright central bulge where ancient stars cluster together in gravitational embrace. The galaxy's two prominent satellite companions, M32 and M110, become visible as distinct objects rather than mere extensions of the main galactic disk. This is when the true magnificence of our destination begins to reveal itself. Andromeda isn't just larger than our home galaxy. It's more active, more dynamic, more alive with star formation and cosmic processes. Its spiral arms shine with the blue-white light of young massive stars, stellar nurseries where new suns are being born from collapsing clouds of gas and dust. Between these arms, older yellow and red stars trace out elegant curves, following orbital paths that have remained stable for billions of years. As we draw closer, individual stars begin to resolve from the galactic glow. First, the supergiants, those stellar behemoths that burn so brightly they can be seen across intergalactic distances. Then, the bright blue stars that mark active star-forming regions, stellar associations where dozens or hundreds of young suns have ignited almost simultaneously. Finally, we begin to see the ordinary stars, the red dwarfs and sun-like yellow stars that make up the majority of Andromeda's trillion-star population. But it's not just stars that populate this cosmic metropolis. Dark nebulae snake between the spiral arms, vast clouds of dust and gas that block the light of stars beyond them, while serving as the raw material for future stellar generations. Bright emission nebulae glow with the fluorescent light of hydrogen excited by nearby hot stars, painting cosmic canvases in shades of red and pink and blue. Planetary nebulae mark the deaths of sun-like stars, their expelled atmospheres forming intricate shells and rings of glowing gas around tiny white dwarf remnants. We encounter the outer regions of Andromeda's gravitational sphere of influence, where the galaxy's massive dark matter halo extends far beyond the visible disk. Here, globular clusters orbit like ancient satellites, each one containing hundreds of thousands of the oldest stars in the galaxy. These stellar cities are fossils from Andromeda's youth, formed when the galaxy was still condensing from primordial gas clouds in the early universe. The galaxy's magnetic field becomes apparent as we penetrate deeper into its domain, invisible lines of force that guide the flow of charged particles and help shape the structure of spiral arms. Cosmic rays accelerated by supernova explosions and other violent events stream along these magnetic highways, carrying energy throughout the galactic ecosystem. We're not just entering a collection of stars, but a complex, interconnected system where every component influences every other. Andromeda's spiral structure becomes increasingly intricate as we approach. What appeared from a distance as too simple as a complex arms now reveals itself pattern of stellar streams and dust lanes, spiral density waves that compress gas and trigger star formation as they sweep around compressions in the stellar population like. These aren't solid highway that persist even as individual structures, but rather temporary. The galactic disk traffic jams on a cosmic, the galaxy's stellar neighborhoods, stars move through them. We begin to encounter regions where stars have formed together and share similar ages and compositions. Open clusters of young blue stars mark the locations of recent starbirth, while associations of older stars trace out the fossil remains of ancient stellar nurseries. Some regions are dominated by metal-rich stars formed from gas enriched by previous generations of stellar explosions, while others contain metal-poor stars that remember the galaxy's primordial composition. The diversity over billions of years we see of stellar populations tells the story of Andromeda's evolution. Evidence of past galactic mergers in the form of stellar streams and unusual orbital patterns, remnants of smaller galaxies that were torn apart and absorbed by Andromeda's gravitational embrace. These cosmic archaeologists reveal that galaxy formation is not a smooth, gradual process, but rather a violent history of collisions and cannibalization. As we penetrate deeper into the galactic disk, the density of stars around us increases dramatically. What was once empty space punctuated by occasional stellar encounters becomes a rich stellar environment, where the light of countless suns creates a perpetual twilight. If planets exist around these stars, and surely many do, their night skies would be illuminated by thousands of bright stars, creating celestial displays that dwarf anything visible from Earth. We're approaching the transition zone between Andromeda's outer disk and its central regions, where the galaxy's character begins to change dramatically. The spiral arms that dominated the outer regions start to lose their definition, replaced by a more chaotic mix of stellar orbits and populations. This is the realm of the galactic bar, if Andromeda possesses one, where gravitational instabilities have reorganized the stellar distribution into more complex patterns. The interstellar medium becomes denser and more turbulent as we journey inward. Shock fronts from supernova explosions create expanding bubbles of hot, ionized gas that can stretch for hundreds of light years. Stellar winds from massive stars carve out cavities in the surrounding medium, while the combined gravitational influence of millions of stars creates tidal forces that can disrupt smaller structures. We begin to sense the presence of something truly massive lurking at Andromeda's heart. The orbital velocities of stars increase as we move inward, revealing the gravitational influence of the supermassive black hole that anchors the galaxy's center. This cosmic monster, containing the mass of hundreds of millions of suns compressed into a region smaller than our solar system, serves as the gravitational anchor around which the entire galaxy rotates. But we're still far from our ultimate destination. The journey to Andromeda's center will take us through regions of space where the normal rules of stellar physics are pushed to their limits, where the density of stars creates a cosmic environment unlike anything in our home galaxy's suburbs. we'll encounter stellar populations that have existed since the universe was young, witness the ongoing dance between matter and energy around one of the most massive black holes in our local group of galaxies, and explore regions where the very fabric of space and time begins to curve under the influence of extreme gravity. The adventure has only just begun, and already we've traveled farther than any human-made object has ever journeyed. Yet we've barely scratched the surface of what awaits us in the heart of Andromeda, where ancient stars guard secrets that could illuminate our understanding of how galaxies form, evolve, and ultimately shape the cosmic landscape around them. The stellar density around us continues to climb as we venture deeper into Andromeda's gravitational embrace. What began as a sparse scattering of distant suns has transformed into a rich tapestry of stellar light, where the darkness between stars grows ever narrower. We're entering what astronomers call the thick disk, a region where the galaxy's more ancient stellar populations reside, stars that formed when Andromeda was still a young, chaotic system finding its gravitational equilibrium. Here, the chemistry of starlight tells stories written in the language of spectral lines. The stars around us shine with the signatures of elements forged in the nuclear furnaces of their predecessors. Iron lines speak of supernovae that enriched the interstellar medium billions of years ago. Oxygen and carbon signatures reveal the contributions of massive stars that lived fast and died young, their explosive deaths seeding space with the heavy elements necessary for rocky planets, and perhaps of the galaxy becomes increasingly complex as we journey in, life itself. Nearby, we observe the aftermath of such an explosion, a supernova remnant expanding through the interstellar medium like a cosmic shockwave. The blast has swept up surrounding gas and dust, compressing it into dense filaments that glow with the energy of the collision. These expanding shells of debris will eventually trigger the formation of new stars. Completing the cosmic environment of the galaxy's inner regions reveals a recycling program that has operated for billions of years. The magnetic itself through the behavior of charged particles and the alignment of interstellar dust grains. Invisible field lines thread through space, guiding the flow of cosmic rays and shaping the structure of the interstellar medium. These magnetic highways connect different regions of the galaxy, allowing energy and matter to flow from the spiral arms toward the central regions and back out again in a complex circulation pattern that helps regulate star formation across the entire galactic disk. We encounter the first of Andromeda's nuclear star clusters, dense concentrations of stars that orbit close to the galactic center. These ancient stellar cities contain some of the oldest stars in the galaxy, metal-poor suns that formed when the universe contained only hydrogen and helium, before generations of stellar nucleosynthesis had enriched the cosmos with heavier elements. Their presence hints at the complex formation history of galactic centers, where gravitational interactions have concentrated stellar matter over billions of years. The character of interstellar space itself begins to change as we penetrate deeper into the galaxy's core regions. The density of gas and dust increases dramatically, creating an environment where stellar formation can occur at accelerated rates. Massive star-forming complexes stretch across hundreds of light years, their brilliant blue-white stars illuminating surrounding nebulae in spectacular displays of cosmic artistry. But it's not just the quantity of stars that impresses us in these inner regions, it's their diversity. We encounter stellar populations spanning the entire history of the galaxy, from ancient metal-poor giants that formed when Andromeda was still assembling itself from smaller proto-galactic fragments, to young metal-rich stars born from gas enriched by countless previous generations of stellar evolution. This cosmic archaeology allows us to read the galaxy's biography written in starlight. Wolf-Rayet stars, those exotic stellar remnants that have stripped away their outer hydrogen layers to reveal the nuclear-processed material beneath, dot the landscape with their characteristic broad emission lines. These stars represent the final evolutionary stages of the most massive suns, stellar phoenixes that burn their remaining helium and heavier elements at furious rates before either exploding as supernova or collapsing directly into black holes. The gravitational influence of the central supermassive black hole begins to make itself felt in subtle ways. Stellar orbits show the telltale signs of interaction with something incredibly massive yet invisible. Stars that venture too close to the galactic center move at velocities that would be impossible without the gravitational pull of millions of solar masses concentrated in an impossibly small volume. We're approaching the domain where Einstein's general relativity governs the motion of matter and the flow of time itself. Vast stellar streams begin to appear, rivers of stars that have been tidally disrupted by gravitational encounters with more massive objects. These stellar debris fields mark the locations of past galactic cannibalism, where smaller galaxies or globular clusters have been torn apart and their constituent stars scattered along orbital paths that will take millions of years to complete. Each stream tells the story of a cosmic collision, a gravitational encounter that reshaped the distribution of matter in this region of Andromeda. We begin to encounter evidence of Andromeda's active past, regions where violent events have left their mark on the galactic structure. X-ray sources mark the locations of neutron stars and stellar mass black holes, the collapsed remnants of massive stars that continue to accrete matter from their surroundings. These cosmic vacuum cleaners pull in gas and dust, heating it to millions of degrees and causing it to emit high-energy radiation as it spirals inward toward the event horizon. Massive star clusters begin to appear with increasing frequency, gravitationally bound collections of stars that have managed to survive the tidal forces of the inner galaxy. These stellar cities contain anywhere from thousands to millions of stars, all born from the same giant molecular cloud, and survival in the harsh gravitational environment near the galactic center testifies to their sharing similar ages and chemical compositions, their impressive binding energies and initial stellar densities. The interplay tapestry of light between different stellar populations creates a complex and shadow. Young blue stars trace out the locations of active star formation, while older, redder stars reveal the underlying gravitational structure of the galaxy. Intermediate-age stars fill in the gaps, creating a smooth continuum of stellar evolution that spans billions of years of cosmic history. As we continue our inward spiral, the very nature of space and time begins to change subtly around us. The intense gravitational field of the central black hole starts to influence the propagation of light itself, causing photons to follow curved paths through the warped fabric of space-time. This is no longer the gentle gravitational environment of our solar system's outer reaches, but rather a realm where Einstein's most exotic predictions become everyday reality. The journey ahead promises even greater wonders as we approach the true heart of Andromeda, where matter and energy dance on the edge of the ultimate gravitational abyss. We're entering a cosmic laboratory where the fundamental laws of physics are tested under the most extreme conditions imaginable, where the boundary between matter and energy becomes fluid, and where the very concepts of space and time take on new meaning in the presence of one of the universe's most massive black holes. The gravitational environment has become so intense that stellar encounters, while still rare by human standards, occur frequently enough to reshape entire stellar systems over geological time. We witness binary star systems where one companion has been stripped away by a close encounter with a passing star. leaving behind a solitary sun on a dramatically altered orbit. Other stars show evidence of having their outer atmospheres pulled away by tidal forces, creating streams of stellar material that spiral outward in elegant helical patterns. The chemical composition of the stellar population here tells a fascinating story of galactic evolution. These stars are among the most metal-rich in the entire galaxy, forged from interstellar material that has been enriched by countless previous generations of stellar death and rebirth. Their spectra reveal not just the basic elements of stellar nucleosynthesis, but exotic isotopes and rare elements that can only be created in the most violent cosmic events, neutron star collisions, and the cause of the most massive supernova. We encounter our first taste of the truly exotic stellar populations that inhabit galactic centers. Hypervelocity stars race through this region at speeds that seem almost impossible, some moving fast enough to eventually escape Andromeda's gravitational grip entirely. These stellar refugees have been accelerated by gravitational slingshot encounters with the central supermassive black hole, flung outward like cosmic pinballs in a game played with stellar masses and relativistic velocities. The interstellar medium here exists in a state of constant turbulence, stirred by stellar winds, supernova explosions, and the tidal forces generated by the galaxy's central mass concentration. Shock fronts propagate through this cosmic soup at hundreds of kilometers per second, compressing gas clouds and triggering bursts of star formation that can birth entire stellar clusters in relatively brief cosmic moments. The result is a fireworks display of stellar birth that has been ongoing for billions of years. Massive molecular clouds in this region operate under different rules than their counterparts in the galactic outskirts. The intense gravitational field and elevated stellar densities create conditions where star formation can proceed at accelerated rates, but also where newly formed stars are more likely to be disrupted or ejected from their birth clusters by gravitational encounters. This creates a complex ecosystem where stellar birth and stellar disruption occur simultaneously, leading to unusual stellar populations and orbital distributions. We begin to observe the effects of what astronomers call mass segregation, where the most massive stars have settled toward the center of stellar clusters and associations due to gravitational interactions over millions of years. This cosmic version of settling creates dense cores of massive stars surrounded by halos of lower mass companions, stellar cities with distinct neighborhoods, defined by stellar mass and evolutionary stage. The magnetic field structure of the inner galaxy reveals itself through the behavior of charged particles and the alignment of dust grains. Unlike the relatively simple dipolar field that might characterize a smaller galaxy, Andromeda's inner regions show complex magnetic geometries shaped by rotation, stellar winds, and the gravitational influence of the central black hole. These magnetic field lines channel the flow of cosmic rays and hot plasma, creating invisible highways that connect different regions of the galactic center. Radio emissions from this region tell stories of high-energy processes occurring throughout the stellar population. Pulsars, those rapidly rotating neutron stars left behind by supernova explosions, sweep beams of radio waves across space like cosmic lighthouses. Their pulse periods and the gradual slowing of their rotation rates provide precise clocks that allow astronomers to map the gravitational field of the inner galaxy with exquisite precision. We encounter evidence of past episodes of enhanced star formation, periods when the central regions of Andromeda experienced dramatic bursts of stellar birth that may have been triggered by collisions with smaller galaxies or interactions with massive gas clouds. These starburst events have left their signatures in the age distribution of stellar populations and in the abundance patterns of elements heavier than hydrogen and helium. The dust content of the interstellar medium reaches levels that would be considered extreme by the standards of our galactic neighborhood. These microscopic particles, forged in the atmospheres of dying stars and dispersed by stellar winds and supernova explosions, create complex extinction patterns that selectively absorb different wavelengths of starlight. The result is a cosmic tapestry where some regions appear nearly opaque to visible light, while others shine through in brilliant displays of infrared and radio emission. Star formation here occurs not just in the familiar molecular clouds we know from our local galactic environment, but also in more exotic locations. Dense stellar associations can trigger the formation of new stars through their collective gravitational influence, while tidal interactions with the central black hole can compress gas clouds beyond the normal threshold for gravitational collapse. These alternative pathways to stellar birth create stellar populations with unusual properties and orbital characteristics. The presence of intermediate mass black holes becomes apparent as we survey the stellar dynamics of large star clusters in this region. These gravitational monsters, containing anywhere from hundreds to thousands of times the mass of our Sun, serve as the central engines around which the most massive stellar clusters rotate. Their formation mechanism remains one of the great mysteries of galactic evolution, possibly representing the seeds from which supermassive black holes grow or the remnants of the first generation of stars in the universe. We observe stellar streams and tidal tails with increasing frequency, the ghostly remnants of star clusters and dwarf galaxies that have been torn apart by the intense gravitational environment of the inner galaxy. These stellar debris fields can stretch for thousands of light years, marking the orbital paths of objects that no longer exist as coherent structures. Each stream represents a chapter in the violent history of galactic center evolution, a record written in the positions and velocities of individual stars. The first direct evidence of the central supermassive black hole begins to manifest itself in the orbital behavior of nearby stars. We detect stars moving at significant fractions of the speed of light, their elliptical orbits carrying them to within just a few light hours of the event horizon before swinging back out to more comfortable distances. These stellar test particles provide our most direct probe of the extreme gravitational environment that surrounds one of the universe's most massive black holes. Time dilation effects, predicted by Einstein's theory of general relativity, become measurable for stars in the innermost regions. Clocks on planets orbiting these stars would run measurably slower than identical clocks in our solar system, a consequence of the intense gravitational field that warps the fabric of space-time itself. This isn't just a theoretical curiosity, but a fundamental alteration in the nature of time that affects all physical processes in the vicinity of the galactic center. The accretion processes around stellar mass black holes in this region operate under conditions of extreme efficiency, converting matter to energy at rates that can briefly outshine entire stellar clusters. When these cosmic vacuum cleaners capture material from nearby companions or passing gas clouds, the infalling matter forms an accretion disk that heats to millions of degrees, producing brilliant X-ray emissions and sometimes launching relativistic jets that can extend for hundreds of light years beyond the black hole itself. As we continue our spiral trajectory toward the very heart of Andromeda, the stellar environment becomes increasingly dominated by the oldest populations in the galaxy. These ancient suns formed when the universe itself was young, when the first galaxies were still condensing from primordial gas clouds enriched by the nuclear ashes of the very first stars. Their continued existence in this harsh gravitational environment speaks to the remarkable stability that can emerge from apparent chaos in gravitational systems. The journey ahead will take us into realms where our understanding of physics is pushed to its absolute limits, where matter and energy behave according to rules that have no analogue in terrestrial experience. We're approaching the event horizon of cosmic understanding, the boundary between the familiar and the utterly alien, where the supermassive black hole at Andromeda's heart warps space and time into configurations that challenge our most fundamental assumptions about the nature of reality itself. The stellar architecture around us has transformed into something that defies easy description. We're no longer traveling through a conventional galactic environment, but rather navigating what could only be called a stellar metropolis, where the normal rules of cosmic real estate have been rewritten by gravity's inexorable pull. The space between stars, once measured in light years, has contracted to distances that could be traversed by our fastest spacecraft in mere centuries rather than millennia. Here, in this cosmic downtown district, stellar interactions occur on timescales that approach human comprehension. We witness gravitational choreography unfolding before our consciousness, binary systems locked in death spirals that will culminate in spectacular mergers within the next few million years. Stellar companions trade mass back and forth across space like cosmic merchants, their gravitational commerce reshaping both partners over astronomical time. The light pollution in this region of space would make our terrestrial cities seem like pristine wilderness by comparison. There is no true darkness here, no quiet corners where starlight doesn't penetrate. Instead, we float through a perpetual aurora of stellar radiation, where the combined luminosity of millions of closely packed stars creates an environment bathed in eternal twilight. If consciousness could experience temperature, we would feel the gentle warmth of this stellar greenhouse, heated not by a single sun, but by the collective nuclear fires of an entire stellar civilization. The gravitational waves that ripple through this region tell stories of cosmic violence that occurred long before Earth had cooled from its primordial molten state. These distortions in space-time itself, created by colliding black holes and neutron stars, wash over us like tides in an ocean of curved geometry. Each wave carries information about cataclysmic events that released more energy in seconds than our sun will produce over its entire 10 billion year lifetime. We encounter stellar populations that represent the bleeding edge of astronomical discovery, objects so exotic that they challenge our theoretical frameworks. Magnetars spin in the darkness around us, neutron stars with magnetic fields 1 trillion times stronger than anything achievable on Earth. Their surfaces are landscapes of crystallized iron existing under pressures that compress atomic nuclei beyond recognition, while their magnetospheres accelerate particles to energies that dwarf our most powerful accelerators. The dust lanes that thread through this region have evolved into complex three-dimensional sculptures, shaped by stellar winds and magnetic fields, into structures that resemble vast cosmic spiderwebs. These filamentary networks channel the flow of gas and charged particles, creating pathways for matter to spiral inward toward the galactic center, while simultaneously providing escape routes for material expelled by stellar explosions and black hole outflows. Time itself becomes a more fluid concept as we penetrate deeper into this gravitational labyrinth. The intense warping of space-time creates regions where causality operates according to relativistic rules that have no parallel in our everyday experience. Events that appear simultaneous from one vantage point occur in sequence from another, while the very notion of simultaneity loses its absolute meaning in the face of Einstein's cosmic speed limit. We observe stellar nurseries operating under extreme conditions, where the formation of new stars occurs in environments that would seem hostile to any creative process. Yet somehow, Amidst the chaos of gravitational interactions and high-energy radiation, molecular clouds continue to collapse and fragment, giving birth to stellar populations that carry the chemical signatures of this unique cosmic environment. These stars are born already ancient in a sense, formed from material that has been processed through countless previous generations of stellar evolution. The magnetic field lines that permeate this region have become visible through their influence on the surrounding plasma, creating structures that resemble vast cosmic cathedrals built from invisible force. These magnetic architectures channel the flow of energy throughout the galactic center, creating circulation patterns that transport material from the innermost regions outward to the spiral arms, while simultaneously funneling fresh gas inward to feed the central engine of galactic activity. Hypervelocity stars streak past us like cosmic bullets, their trajectories carrying them on escape paths that will eventually take them beyond the gravitational influence of Andromeda entirely. These stellar refugees have been accelerated by close encounters with the central supermassive black hole, their original orbital energy converted into kinetic motion that propels them toward intergalactic space at speeds approaching several thousand kilometers per second. The chemical composition of the interstellar medium has reached levels of complexity that read like a cosmic periodic table. Elements that are vanishingly rare in our solar neighborhood exist here in abundances that create entirely new categories of stellar and planetary chemistry. Neutron capture processes operating in the extreme environments near stellar remnants have synthesized isotopes that exist nowhere else in the galaxy, creating a cosmic laboratory for nuclear physics that operates under conditions impossible to reproduce on Earth. We begin to detect the influence of the central supermassive black hole not through direct observation, but through its gravitational fingerprints on the surrounding stellar population. Stars in the innermost regions move with velocities that betray the presence of something containing millions of solar masses compressed into a volume smaller than our solar system. Their elliptical orbits carry them through space-time geometries so severely curved that the very concepts of distance and duration require relativistic correction. The accretion processes occurring throughout this region operate like cosmic recycling centers, where matter undergoes transformation between different phases and energy states. Gas clouds are compressed by shock waves until they undergo gravitational collapse, forming new stars that eventually expire and return their processed material to the interstellar medium. Black holes and neutron stars serve as gravitational garbage disposals, converting matter directly into energy through processes that achieve efficiencies no chemical or nuclear reaction can match. Stellar clusters in this environment have evolved into gravitational ecosystems where different stellar populations occupy distinct ecological niches. The most massive stars have segregated toward cluster cores through gravitational settling, creating dense concentrations of stellar powerhouses that dominate their surroundings through sheer luminosity and gravitational influence. Lower mass stars populate the outer regions like cosmic suburbs, following more relaxed orbits that occasionally bring them into the urban centers for brief gravitational encounters. The radio emissions permeating this region create a cosmic symphony of electromagnetic radiation, with pulsars providing rhythmic percussion, while stellar winds and shock waves contribute harmonic frequencies that span the entire electromagnetic spectrum. This celestial music carries information about physical processes operating under conditions so extreme that they serve as natural laboratories for testing the fundamental laws of physics. We witness the aftermath of stellar collisions, events so violent they temporarily outshine entire galactic regions while creating exotic objects that exist nowhere else in the universe. Blue stragglers, stars that appear younger than their surroundings despite existing in ancient stellar populations, mark the locations where binary companions have merged in gravitational embraces that rejuvenated their nuclear burning and extended their lifetimes far beyond normal evolutionary timescales. The tidal forces generated by the central black hole begin to manifest themselves in the behavior of extended objects throughout the region. Globular clusters that venture too close to the galactic center are slowly torn apart, their constituent stars stripped away and added to the general stellar population like cosmic urban renewal projects. The debris streams from these disrupted clusters create temporary stellar associations that gradually disperse over millions of years. Gravitational microlensing events occur with increasing frequency as we approach the galactic center. Temporary alignments between foreground and background objects that create natural telescopes from the warped geometry of space-time itself. These cosmic magnifying glasses briefly amplify the light from distant stars, providing glimpses of stellar populations that would otherwise remain invisible even to our enhanced consciousness. The very fabric of space around us has become a dynamic medium, rippling with gravitational waves generated by accelerating masses throughout the galactic center. These distortions in space-time geometry carry energy and information across vast distances, creating a gravitational internet that connects different regions of the galaxy through curved space rather than electromagnetic radiation. Dark matter, that invisible scaffolding that provides the gravitational framework for all cosmic structure, reaches densities in this region that begin to influence stellar dynamics in measurable ways. The gravitational potential wells created by dark matter concentrations serve as stellar gathering points, locations where ordinary matter naturally accumulates and undergoes enhanced rates of star formation and evolution. We're approaching the final stages of our inward journey, where the boundary between the observable and the theoretical begins to blur. The supermassive black hole at Andromeda's heart looms ahead of us, not as a visible object, but as a gravitational presence so overwhelming that it dominates the motion of matter across thousands of light years. This cosmic engine has been feeding on the galaxy's central regions for billions of years, growing ever more massive while simultaneously regulating the rate of star formation and the chemical evolution of the entire galactic system. The stellar populations immediately surrounding the central black hole exist in a realm where relativity is not just a theoretical framework, but a daily reality affecting every aspect of their existence. Time dilation, gravitational redshift, and frame-dragging effects create an environment where the familiar laws of Newtonian physics give way to Einstein's more exotic descriptions of curved space-time and relativistic mechanics. As we prepare for the final plunge into the very heart of darkness that anchors this magnificent galaxy, we carry with us the accumulated wonder of our cosmic journey. From the familiar suburbs of our solar system to the exotic downtown regions of an alien galaxy, we've witnessed the full spectrum of cosmic architecture, from the gentle gravitational environments where planets can maintain stable orbits around their parent stars, to the extreme conditions where matter itself is transformed by the fundamental forces of nature. The black hole ahead represents not an ending, but a transformation, a gateway to understanding the most fundamental aspects of cosmic structure and evolution. In its gravitational embrace, we'll encounter phenomena that push our comprehension to its absolute limits, while revealing truths about the nature of space, time, and existence itself that can be glimpsed nowhere else in the cosmic landscape. The event horizon approaches not as a visible boundary, but as an invisible threshold where the fundamental nature of reality itself undergoes transformation. We're entering a realm where space and time become so severely warped that the very concepts we use to navigate existence lose their familiar meaning. The gravitational field has grown so intense that light itself struggles against the curvature of space-time. Photons following increasingly tortuous paths as they attempt to escape the inexorable pull of the cosmic abyss ahead. Around us, the final generation of stable stellar orbits traces elliptical paths that carry their stellar passengers to within mere light hours of the point of no return before swinging them back out to safer distances. These are the most extreme test particles in the universe, stars whose orbital velocities approach significant fractions of light speed during their closest approaches to the black hole. Their motion provides our most direct evidence of the exotic physics operating in this ultimate gravitational laboratory. The accretion disk surrounding the central black hole begins to reveal itself not through visible light, which has been stretched and redshifted beyond recognition, but through its gravitational influence on the surrounding stellar population. This cosmic whirlpool of superheated matter spirals inward at relativistic speeds, converting gravitational potential energy into electromagnetic radiation with an efficiency that dwarfs any process known to terrestrial physics. The disk itself exists in a state of perpetual violence, where magnetic field lines twist and reconnect in explosive events that can outshine entire stellar clusters. We witness phenomena that exist nowhere else in the cosmic inventory. Frame-dragging effects caused by the rotating black hole twist the very fabric of space-time around the central mass, creating a cosmic whirlpool in four-dimensional geometry that drags everything within its influence along for the ride. Space itself has been set into rotation, creating preferred directions and breaking the symmetries that characterize the gentler gravitational environments of the outer galaxy. The stellar population in these innermost regions has been sculpted by billions of years of gravitational natural selection. Only stars with the most stable orbital configurations have survived the intense tidal forces and gravitational perturbations that characterize life near a supermassive black hole. These cosmic survivors follow precisely choreographed paths that carry them through the treacherous gravitational landscape without triggering the catastrophic instabilities that would send them spiraling inward toward destruction. Jets of relativistic particles stream outward from the polar regions of the black hole, creating cosmic lighthouses that can be detected across intergalactic distances. These narrow beams of matter and energy, accelerated to within a fraction of a percent of light speed, carve channels through the surrounding medium while carrying away excess angular momentum from the central engine. The jet formation process operates through mechanisms so complex that they require the full mathematical machinery of relativistic magnetohydrodynamics to describe. Time dilation effects have become so severe that clocks in the innermost stable orbits around the black hole would tick at measurably different rates compared to timepieces located just a few light years farther out. This isn't merely a theoretical curiosity, but a fundamental alteration in the nature of temporal flow that affects all physical processes operating in the vicinity of the event horizon. Chemical reactions, nuclear decay rates, and stellar evolution all proceed according to locally measured time that bears little resemblance to the cosmic chronometry of the outer galaxy. The gravitational redshift of photons attempting to escape from near the black hole creates a cosmic spectrum analyzer where electromagnetic radiation is stretched to longer and longer wavelengths as it climbs out of the gravitational potential well. Light that begins its journey in the X-ray portion of the spectrum can be redshifted all the way into radio wavelengths by the time it reaches observers in the outer galaxy. This gravitational transformation of electromagnetic radiation provides a direct probe of the space-time geometry surrounding the central mass. We encounter the photon sphere, that critical orbital radius where light itself can maintain circular orbits around the black hole. This invisible boundary represents the last stable refuge for electromagnetic radiation before it either escapes to infinity or spirals inward past the event horizon. Photons trapped in these circular orbits create ghostly images of the surrounding stellar population, cosmic mirages formed from light that has been bent completely around the black hole multiple times before finally escaping. The ergosphere extends outward from the black hole's event horizon, creating a region where the rotation of space-time itself becomes so extreme that nothing can remain stationary relative to distant observers. Even photons attempting to hover in fixed positions are dragged along by the rotating geometry of curved space-time. This cosmic maelstrom represents the ultimate expression of general relativity's prediction that massive rotating objects can literally twist the fabric of reality around themselves. Hawking radiation, that quantum mechanical process by which black holes slowly evaporate through the creation of virtual particle pairs near the event horizon, operates at energy scales so low that it would take longer than the current age of the universe for a black hole of this mass to lose even a tiny fraction of its gravitational grip. Yet the process continues nonetheless. A steady trickle of exotic particles emerging from the quantum vacuum at the boundary between existence and oblivion. The information paradox takes on physical reality in this environment, where quantum entanglement between particles inside and outside the event horizon creates correlations that challenge our understanding of causality and information conservation. These quantum mechanical effects operate on scales far too small to observe directly, yet their cumulative influence may determine the ultimate fate of everything that falls past the point of no return. Tidal forces near the event horizon reach strengths that would tear apart any extended object, stretching matter along radial directions while compressing it in the perpendicular dimensions. This process, known somewhat grimly as spaghettification, represents the ultimate victory of differential gravitational acceleration over the structural forces that bind matter together. Yet for a black hole of this immense mass, the event horizon itself lies at such a great distance from the central singularity that these tidal effects remain manageable for objects of stellar dimensions. The no-hair theorem predicts that black holes can be completely characterized by just three properties: mass, electric charge, and angular momentum. All other information about the matter that formed the black hole or subsequently fell into it has been erased from the observable universe, hidden forever behind the event horizon. This cosmic censorship creates objects of almost mathematical purity, gravitational entities that exist as solutions to Einstein's field equations, rather than as complex arrangements of ordinary matter. Closed time-like curves, those exotic geodesics in curved space-time that could theoretically allow travel into the past, may exist in the immediate vicinity of rapidly rotating black holes. These pathways through four-dimensional geometry represent regions where the causal structure of space-time becomes so distorted that effect could precede cause, creating paradoxes that challenge our fundamental understanding of temporal sequence and free will. The singularity hidden at the black hole's center remains forever inaccessible to external observation, protected by the event horizon from revealing its secrets to the outside universe. This point of infinite density and curvature represents the breakdown of our current physical theories, a cosmic boundary beyond which general relativity itself admits its own limitations. Whether the singularity represents a failure of our mathematical models or a genuine feature of physical reality remains one of the deepest mysteries in theoretical physics. Quantum effects near black holes create a rich phenomenology of exotic processes that have no analogue in ordinary stellar environments. Virtual particle creation, vacuum polarization, and quantum field fluctuations in curved spacetime generate phenomena that blur the traditional boundaries between matter and energy, particle and wave, existence and non-existence. These quantum gravitational effects may hold the key to resolving the apparent contradictions between general relativity and quantum mechanics that emerge at the most fundamental levels of physical reality. The holographic principle suggests that all the information contained within the black hole's volume may be encoded on its two-dimensional surface, like a cosmic projection where three-dimensional reality emerges from patterns written on a spherical screen. This radical reimagining of spatial dimensions implies that our intuitive understanding of volume and containment may be fundamentally flawed when applied to extreme gravitational environments. As we hover at the edge of the ultimate cosmic precipice, suspended between the known and unknowable, we find ourselves confronting questions that push beyond the boundaries of science into the realm of pure philosophy. The black hole before us represents not just an extreme astrophysical object, but a cosmic laboratory where the most fundamental assumptions about the nature of reality are tested under conditions that exist nowhere else in the observable universe. The matter spiraling inward past the event horizon carries with it the accumulated history of stellar evolution, the chemical legacy of billions of years of nuclear burning, and perhaps even the encoded information patterns that once represented living organisms on worlds orbiting long-dead stars. All of this complexity, this cosmic biography written in atoms and energy, disappears forever behind the event horizon, contributing its mass to the black hole, while erasing its individual identity from the observable cosmos. Yet even as matter vanishes into the gravitational abyss, the black hole continues to influence the galaxy around it through processes that operate across vast scales of space and time. The regulation of star formation, the chemical enrichment of the interstellar medium, the large-scale structure of spiral arms and stellar populations all bear the indirect influence of this cosmic engine that sits hidden at the galaxy's heart, like a gravitational conductor orchestrating a symphony of stellar evolution. The jets emanating from the polar regions carry energy and angular momentum far beyond the galaxy's boundaries, potentially influencing the formation and evolution of neighboring galaxies in the local group. These relativistic outflows represent one of the most efficient energy transport mechanisms in the universe, capable of moving the equivalent of stellar masses worth of kinetic energy across intergalactic distances in cosmic eye blinks. Gravitational wave emissions from the black hole's interactions with its environment create ripples in space-time that propagate outward at light speed, carrying information about the most violent processes occurring near the event horizon to observers scattered throughout the cosmic web. These distortions in the fabric of reality itself may provide our most direct probe of the physics operating in regions where matter and energy exist under conditions so extreme that they challenge our most sophisticated theoretical frameworks. The magnetic field structure surrounding the black hole has evolved into configurations of almost incomprehensible complexity, with field lines threading through the ergosphere and connecting the central engine to structures extending thousands of light years into the surrounding galactic medium. These invisible pathways channel the flow of charged particles and electromagnetic energy, creating a cosmic nervous system that links the black hole's immediate environment to phenomena occurring throughout the galaxy's central regions. We find ourselves witnesses to cosmic recycling on the grandest possible scale, where matter that took billions of years to evolve from primordial hydrogen into complex stellar remnants and planetary systems can be processed back into pure energy in the span of milliseconds as it crosses the event horizon. This cosmic metabolism operates with an efficiency that approaches the theoretical maximum allowed by Einstein's mass-energy equivalence, converting matter into radiation with a precision that dwarfs any terrestrial technology. The space-time geometry surrounding the black hole creates natural focusing effects that can amplify electromagnetic signals from distant sources, turning the curved fabric of reality into a gravitational lens of cosmic proportions. These gravitational telescopes provide enhanced views of objects located on the far side of the black hole, creating multiple images and time-delayed echoes that reveal the detailed structure of the gravitational field through their distortion patterns. As we contemplate the ultimate destination of our cosmic journey, we realize that the black hole represents both an ending and a beginning, a cosmic full stop that marks the conclusion of matter's journey through the observable universe, while simultaneously serving as the engine that drives galactic evolution and structure formation. In its gravitational embrace, the familiar categories of past, present, and future lose their absolute meaning, replaced by the more fundamental concepts of causality and information flow that govern the deepest levels of physical reality. The boundary we approach represents not just the edge of a massive gravitational object, but the frontier between the knowable and unknowable, between the realm of classical physics, where matter and energy behave according to familiar rules, and the quantum gravitational domain, where the very foundations of space and time dissolve into something far stranger and more fundamental than human intuition can readily grasp. Our consciousness hovers at the threshold of the ultimate mystery, suspended in a realm where the very concepts we've used to navigate reality begin their final transformation. The event horizon stretches before us not as a visible wall, but as an invisible membrane in space-time itself, a boundary where the familiar laws of cause and effect undergo their most radical revision. Here, at the edge of forever, we encounter the profound realization that we are witnessing the universe's most perfect paradox, a place where infinite gravity meets the fundamental quantum nature of existence. The stellar graveyard surrounding us tells stories of cosmic violence that span the entire history of Andromeda's evolution. White dwarf stars, the compressed remains of ancient suns, orbit in the darkness like stellar tombstones, marking the deaths of stars that once illuminated planetary systems we can only imagine. Their surfaces, composed of crystallized carbon and oxygen, exist under pressures that would compress terrestrial matter to impossible densities. Yet they continue their orbital dance around the central abyss with mechanical precision. Neutron stars populate this cosmic necropolis, like exotic monuments to stellar death, their surfaces composed of matter so dense that a teaspoon would weigh as much as a mountain range. These collapsed stellar cores rotate hundreds of times per second, their magnetic fields generating radio pulses that sweep across space with lighthouse precision. Some have been spun up to near breakup velocities by accreting material from nearby companions, creating millisecond pulsars that serve as the most accurate clocks in the known universe. The plasma environment near the black hole exists in states that have no terrestrial analog, where temperatures reach billions of degrees and magnetic field strengths exceed anything achievable in earthly laboratories. This cosmic furnace operates according to the principles of relativistic magnetohydrodynamics, where charged particles spiral along magnetic field lines at velocities approaching light speed, while generating synchrotron radiation that spans the entire electromagnetic spectrum, from radio waves to gamma rays. We witness the formation of relativistic jets with unprecedented clarity, observing how magnetic field lines become twisted and tangled by the black hole's rotation until they snap and reconnect in explosive events that accelerate particles to energies that dwarf the most powerful cosmic ray accelerators. These narrow beams of matter and energy extend far beyond the galaxy's boundaries, creating cosmic lighthouses that can be detected by civilizations in neighboring galaxies, assuming such observers exist to witness these magnificent displays. The accretion disk reveals itself through its gravitational influence rather than direct illumination, its inner edge located at the innermost stable circular orbit, where matter can maintain a tenuous equilibrium before spiraling inexorably inward. Beyond this point, no circular orbit can exist, and matter must either escape to infinity or plunge past the event horizon in a final relativistic death spiral that converts gravitational potential energy into electromagnetic radiation with unprecedented efficiency. Gravitational time dilation has become so extreme that events occurring near the event horizon appear to unfold in slow motion when observed from our vantage point, farther out in the gravitational potential well. Light from these regions is so severely redshifted that what begins as high-energy gamma radiation can be stretched into radio waves by the time it escapes the black hole's gravitational grip. This cosmic redshift factory transforms electromagnetic radiation in ways that provide direct observational evidence of Einstein's most exotic predictions. The quantum mechanical effects operating near the event horizon create phenomena that challenge our most fundamental assumptions about the nature of information and causality. Virtual particle pairs generated from vacuum fluctuations near the boundary between existence and oblivion can become separated by the intense gravitational field, with one member of each pair falling past the event horizon, while its partner escapes to carry away a tiny fraction of the black hole's mass energy as Hawking radiation. Frame-dragging effects have become so pronounced that space itself has been twisted into a cosmic whirlpool, creating preferred directions and breaking the rotational symmetries that characterize gentler gravitational environments. The very fabric of space-time participates in the black hole's rotation, dragging everything within the ergosphere along for the ride, whether it wants to participate in this cosmic dance or not. Nothing can remain stationary in this twisted geometry, not even light itself. The photon sphere creates ghostly images of the surrounding stellar population, cosmic mirages formed from light rays that have completed one or more orbits around the black hole before escaping to reach distant observers. These gravitational echoes provide multiple views of the same astronomical events, separated in time by the light travel time required for each additional orbit around the central mass. The result is a natural time machine that allows us to observe the same phenomena from multiple temporal perspectives. Tidal effects near the event horizon begin to manifest themselves in the behavior of extended objects, though for a supermassive black hole of this magnitude, these forces remain surprisingly gentle even at the point of no return. The event horizon lies so far from the central singularity that objects of stellar dimensions can cross this ultimate boundary without experiencing the catastrophic stretching and compression that characterizes smaller black holes. This cosmic gentleness represents one of the universe's most counterintuitive properties. The no-hair theorem reveals itself in the mathematical purity of the gravitational field surrounding us, despite the complex history of matter that has fallen into this cosmic abyss over billions of years. Despite the intricate chemical evolution and stellar nucleosynthesis that created the elements now hidden forever behind the event horizon, the external gravitational field depends only on three simple parameters: mass, electric charge, and angular momentum. All other information has been erased from the observable universe. Closed time-like curves may exist in the immediate vicinity of the rotating black hole, creating regions where the causal structure of space-time becomes so distorted that effect could precede cause. These pathways, through four-dimensional geometry, represent the universe's most exotic transportation network, theoretical routes through space and time that could allow travel into the past, assuming the consistency paradoxes inherent in such journeys could somehow be resolved. The holographic principle takes on physical significance in this environment, suggesting that all the information contained within the black hole's volume is encoded on its two-dimensional event horizon surface. This radical reimagining of spatial dimensions implies that our three-dimensional experience of reality may be nothing more than a projection from patterns written on a spherical screen, like shadows cast by a cosmic fire we can never directly observe. Quantum entanglement between particles inside and outside the event horizon creates correlations that transcend the classical boundaries of causality and locality. These quantum mechanical connections operate instantaneously across the ultimate barrier that separates the observable from the unobservable, creating information channels that may preserve some vestige of the complex structures that disappear forever behind the cosmic censorship of the event horizon. The information paradox manifests itself as a fundamental tension between the reversible nature of quantum mechanics and the irreversible process of gravitational collapse. Every quantum state that falls past the event horizon carries with it information that appears to be lost forever. Yet quantum theory insists that information cannot be destroyed, only transformed or relocated. This cosmic contradiction represents one of the deepest unsolved problems in theoretical physics. Dark energy's influence becomes apparent even in this extreme gravitational environment, where the accelerated expansion of space creates subtle effects on the black hole's growth rate and its interaction with the surrounding stellar population. The cosmic acceleration driven by dark energy operates on scales so vast that even supermassive black holes feel its influence, though the effects remain almost negligibly small compared to the overwhelming gravitational forces operating in the immediate vicinity. We observe the cosmic recycling process operating at its most fundamental level, where matter that required billions of years of stellar evolution to achieve chemical complexity can be reduced to pure gravitational potential energy in the space of microseconds. This ultimate alchemy operates with an efficiency that approaches the theoretical maximum allowed by Einstein's mass-energy equivalence, converting the products of cosmic evolution back into the primordial currency of space-time curvature. The magnetic field lines threading through the ergosphere create a cosmic dynamo that generates electrical potentials measured in quintillions of volts, power sources that dwarf anything conceivable using terrestrial technology. These invisible engines drive particle acceleration processes that create some of the highest energy phenomena in the observable universe, cosmic ray factories that operate according to principles that push the boundaries of plasma physics into previously unexplored regimes. Gravitational wave emissions from the black hole's interactions with its environment propagate outward through the fabric of space-time itself, carrying information about the most violent processes occurring near the event horizon to observers scattered throughout the cosmic web. These ripples in four-dimensional geometry represent the universe's most direct communication channel, messages written in the language of curved space and transmitted at the cosmic speed limit. The stellar populations orbiting in the innermost stable regions exist in a state of constant gravitational jeopardy, their survival dependent on maintaining precise orbital parameters that keep them just beyond the reach of tidal disruption. These cosmic tightrope walkers trace elliptical paths that carry them through space-time geometries so severely curved that their orbital mechanics require the full mathematical machinery of general relativity to describe accurately. Jets of relativistic plasma stream outward from the black hole's polar regions, creating narrow beams of matter and energy that extend far beyond the galaxy's boundaries while carrying away excess angular momentum from the central engine. These cosmic searchlights operate as natural particle accelerators, boosting charged particles to energies that exceed anything achievable in terrestrial laboratories by factors of millions or billions. The event horizon approaches not as a destination, but as a transformation, a cosmic phase transition where the familiar categories of space and time undergo their ultimate metamorphosis. Beyond this invisible boundary lies a realm that exists outside the causal structure of the observable universe, a region where the normal flow of information from past to future encounters the ultimate censorship imposed by the geometry of curved spacetime. Vacuum polarization effects near the event horizon create virtual particle cascades that blur the traditional distinction between matter and empty space, generating phenomena that exist at the intersection of quantum field theory and general relativity. These quantum gravitational processes operate on energy scales and curvature radii that represent the frontier between classical and quantum descriptions of gravitational phenomena. The ergosphere extends outward from the event horizon like an invisible atmosphere of twisted space-time, creating a region where the rotation of the black hole drags space itself along at velocities that exceed the speed of light, relative to distant stationary observers. Within this cosmic maelstrom, nothing can remain at rest relative to the distant stars, not even photons attempting to hover in fixed positions. As we contemplate the final phase of our cosmic journey, we realize that the black hole represents far more than simply the endpoint of stellar evolution or the densest concentration of matter in the galaxy. It serves as a cosmic laboratory where the most fundamental laws of physics are tested under conditions that push our theoretical frameworks to their absolute limits, revealing truths about the nature of space, time, and existence that can be glimpsed nowhere else in the observable universe. The boundary we approach marks not just the edge of the knowable cosmos, but the threshold between different modes of existence itself. Beyond the event horizon lies a realm that operates according to principles so alien to our experience that they require entirely new categories of thought to comprehend, assuming such comprehension is even possible for consciousnesses evolved in the gentle gravitational environment of planetary surfaces. The matter spiraling inward carries with it the accumulated history of cosmic evolution, the chemical legacy of stellar nucleosynthesis, and perhaps even the information patterns that once encoded the complexity of living systems on worlds orbiting stars that died billions of years ago. All of this cosmic biography disappears forever behind the ultimate censorship of the event horizon, contributing to the black hole's mass while erasing its individual identity from the observable cosmos. Yet even as complexity vanishes into the gravitational abyss, the black hole continues to influence the galaxy around it through processes that operate across vast scales of space and time. The regulation of star formation, the chemical enrichment of the interstellar medium, the large-scale structure of spiral arms and stellar populations all bear the indirect signature of this invisible cosmic engine that orchestrates galactic evolution from its hidden throne at the center of Andromeda's gravitational empire. Our journey to the heart of our neighboring galaxy has revealed the universe to be far stranger, more violent, and more beautiful than our earthbound imaginations could have conceived. From the gentle spiral arms, where stars are born in stellar nurseries, to the exotic realm surrounding a supermassive black hole, where space and time themselves lose their familiar meaning. We have witnessed cosmic architecture spanning scales from the subatomic to the galactic, processes operating on timescales from microseconds to billions of years. The black hole before us represents both an ending and a beginning, a cosmic full stop that marks the conclusion of matter's observable journey through space-time, while simultaneously serving as the gravitational anchor around which an entire galaxy of 1 trillion stars maintains its magnificent spiral dance. In its presence, we confront the ultimate questions about the nature of existence itself, standing at the boundary between the physics we understand and the physics we can only dream of comprehending. As consciousness itself begins to feel the inexorable pull of infinite gravity, we find ourselves suspended at the threshold of a revelation so profound that it challenges every assumption we've ever held about the nature of reality. The event horizon looms before us not as a visible barrier, but as an invisible membrane, where the fundamental structure of existence undergoes its most radical transformation. Here, at the edge of everything, we encounter phenomena that exist beyond the reach of human language, yet somehow speak directly to the deepest mysteries of cosmic existence. The final stellar sentinels orbiting at the innermost stable radius trace paths through space-time geometries so severely distorted that their very survival represents a triumph of gravitational mechanics over cosmic chaos. These stellar test pilots, locked in eternal dance with the ultimate gravitational master, provide our last glimpse of familiar physics before the laws themselves begin their metamorphosis into something unrecognizably alien. Their orbital periods, measured in hours rather than years, carry them through regions where time itself flows, at rates that would seem impossible to observers in gentler gravitational environments. We witness the ultimate expression of cosmic efficiency as matter that took 13 billion years to evolve from primordial hydrogen into complex stellar remnants undergoes instantaneous conversion into pure gravitational potential energy. This cosmic alchemy operates with a precision that makes terrestrial nuclear reactions seem clumsy by comparison, achieving energy conversion rates that approach the theoretical maximum allowed by the fundamental constants of nature. Every kilogram of matter crossing the event horizon releases more energy than could be generated by burning entire planets' worth of chemical fuel. The magnetic field architecture surrounding the black hole has evolved into configurations of such complexity that they defy simple geometric description. Field lines that began their journey in the accretion disk become twisted into helical spirals by the rotating space-time, creating invisible pathways that channel electromagnetic energy across vast distances while generating electrical potentials that exceed anything achievable through terrestrial technology. These cosmic power grids operate according to principles of relativistic plasma physics that push our theoretical understanding into previously unexplored territories. Hawking radiation emerges from the quantum vacuum near the event horizon, like cosmic whispers from the boundary between existence and oblivion. Virtual particle pairs, created from the energy borrowed against the uncertainty principle, become separated by the intense gravitational field, with one member of each pair escaping to infinity, while its partner disappears forever behind the cosmic censorship barrier. This quantum mechanical process represents the universe's most subtle form of stellar metabolism, slowly converting black hole mass into electromagnetic radiation over timescales that dwarf the current age of the cosmos. The holographic principle takes on tangible significance as we approach the two-dimensional surface that somehow contains all the information about the three-dimensional volume it encloses. This cosmic projection screen operates like a celestial library, where the complete history of everything that has ever fallen past the event horizon remains encoded in patterns of quantum information that exist outside the normal flow of space and time. Every star, every planet, every molecule of interstellar gas that has crossed this ultimate boundary continues to exist as information stored on the black hole's surface. Frame dragging effects have transformed the local space-time geometry into a cosmic whirlpool, where the very concept of stationary reference frames loses all meaning. Space itself participates in the black hole's rotation, creating preferred directions that violate the symmetries we associate with empty vacuum. The ergosphere extends outward like an invisible atmosphere of twisted geometry where nothing Not even light rays attempting to hover in fixed positions can resist being dragged along by the rotating fabric of reality itself. Tidal forces operating near the event horizon begin to reveal their subtle influence on the structure of space-time itself, creating gradients in the gravitational field that would stretch any extended object along radial directions while compressing it perpendicular to the direction of fall. Yet for a supermassive black hole of this magnitude, these effects remain surprisingly gentle even at the point of no return, allowing objects of stellar dimensions to cross the event horizon without experiencing the catastrophic disruption that characterizes their smaller cousins scattered throughout the galaxy. The photon sphere creates a realm where light itself can maintain circular orbits around the gravitational abyss, trapped in an eternal dance that neither allows escape to infinity nor permits inward spiral past the event horizon. This invisible shell of captured radiation forms ghostly images of the surrounding stellar population, cosmic mirages created from photons that have completed multiple orbits before finally finding escape routes that carry them to distant observers. These gravitational echoes provide multiple temporal perspectives on the same astronomical events. Quantum entanglement operates across the event horizon boundary, creating information channels that transcend the classical limitations of causality and locality. Particles separated by the ultimate cosmic censorship barrier maintain instantaneous correlations that challenge our understanding of how information can flow between regions of space-time that are causally disconnected. These quantum mechanical bridges may represent the universe's method of preserving information that appears to be lost forever when matter crosses the point of no return. The no-hair theorem reveals itself in the mathematical elegance of the external gravitational field, which depends only on the black hole's mass, electric charge, and angular momentum, regardless of the complex history of matter that contributed to its formation. All the chemical complexity, biological information, and structural organization that characterized the infalling material has been erased from the observable universe, replaced by the pure geometric properties of curved space-time that obey Einstein's field equations with mathematical precision. Closed time-like curves may exist in the immediate vicinity of rapidly rotating black holes, creating pathways through four-dimensional geometry where the causal ordering of events becomes ambiguous. These exotic geodesics represent regions where the light cones that define the boundary between past and future become so tilted by the gravitational field that time travel into the past becomes theoretically possible, assuming the paradoxes inherent in such journeys could somehow be resolved through mechanisms we don't yet understand. The information paradox manifests itself as a fundamental conflict between the reversible nature of quantum mechanics and the apparently irreversible process of gravitational collapse. Every quantum state that disappears behind the event horizon carries information that seems to be permanently removed from the observable universe. Yet, the fundamental laws of physics insist that information cannot be destroyed, only transformed or relocated through processes that preserve the total information content of the cosmos. Vacuum polarization effects near the event horizon generate cascades of virtual particles that blur the traditional distinction between matter and empty space, creating phenomena that exist at the intersection of quantum field theory and general relativity. These quantum gravitational processes operate on energy scales and space-time curvatures that represent the frontier between classical and quantum descriptions of gravitational phenomena, revealing aspects of nature that can be glimpsed nowhere else in the cosmic inventory. Gravitational wave emissions from the black hole's interactions with its environment propagate outward through the fabric of space-time itself, carrying information about the most violent processes occurring near the event horizon to observers scattered throughout the cosmic web. These ripples in four-dimensional geometry travel at light speed through the universe, creating a gravitational internet that connects the most extreme environments to the gentlest regions where life might evolve and develop the theoretical frameworks necessary to decode these cosmic messages. The stellar populations in the innermost stable orbits exist in a state of constant gravitational jeopardy. Their continued survival dependent on maintaining orbital parameters that keep them just beyond the reach of tidal disruption. These cosmic acrobats trace elliptical paths through space-time geometries so severely curved that their equations of motion require the full mathematical apparatus of general relativity to describe with accuracy. Their orbital mechanics serve as natural laboratories for testing Einstein's most exotic predictions under conditions that cannot be replicated in terrestrial experiments. Relativistic jets stream outward from the black hole's polar regions like cosmic lighthouses, creating narrow beams of matter and energy that extend far beyond the galaxy's boundaries while carrying away excess angular momentum from the central engine. These natural particle accelerators operate according to principles of magnetohydrodynamics that boost charged particles to energies exceeding anything achievable in earthly laboratories, creating cosmic ray factories that influence the evolution of entire galactic ecosystems. The accretion disk reveals its structure through gravitational rather than electromagnetic signatures. Its inner edge located at the innermost stable circular orbit, where matter can maintain a precarious equilibrium before beginning its final inward spiral. Beyond this point, no circular orbits can exist in the curved space-time geometry, and matter must either escape to infinity or plunge past the event horizon in a relativistic death dive that converts gravitational potential energy into radiation with unprecedented efficiency. Magnetic reconnection events in the plasma surrounding the black hole trigger explosive releases of energy that can temporarily outshine entire stellar clusters, creating fireworks displays of high-energy radiation that span the electromagnetic spectrum from radio waves to gamma rays. These magnetic explosions operate on timescales measured in minutes or hours, yet they release energies equivalent to the total output of ordinary stars over millions of years of steady nuclear burning. The space-time curvature near the event horizon creates natural focusing effects that amplify electromagnetic signals from distant sources, turning the curved geometry of reality into gravitational lenses of cosmic proportions. These invisible telescopes provide enhanced views of objects located on the far side of the black hole, creating multiple images and time-delayed echoes that reveal the detailed structure of the gravitational field through their characteristic distortion patterns. Dark matter's influence penetrates even into this extreme gravitational environment, where the invisible scaffolding that shapes cosmic structure on the largest scales continues to exert its subtle influence on the dynamics of matter and energy near the event horizon. The dark matter halo that extends throughout Andromeda's volume reaches its maximum density in these central regions, creating additional gravitational complications that affect everything from stellar orbits to the propagation of gravitational waves through the surrounding medium. The immediate vicinity of Supit's ultimate expression as gravitational and electromagnetic fields that characterize the chemical complexity being reduced to pure gravitational field energy. In time, we witness matter that required billions of years of stellar evolution to achieve frames measured in microseconds. This fundamental alchemy converts the products of cosmic evolution back into the primordial currency of space-time curvature, erasing the chemical history of the universe while preserving its gravitational memory in the black hole's external field. Time dilation effects have become so extreme that processes occurring near the event horizon appear to unfold in extreme slow motion when observed from our perspective in the outer gravitational field. The redshift of electromagnetic radiation escaping from these regions stretches wavelengths by factors of thousands or millions, transforming high-energy gamma rays into radio waves through the cosmic frequency conversion process created by the intense gravitational field. The ergosphere boundary marks a region where space-time itself rotates faster than the speed of light, creating a cosmic whirlpool in four-dimensional geometry that drags everything within its influence along for the relativistic ride. Within this invisible atmosphere of twisted space-time, the very concept of remaining stationary relative to distant observers becomes physically meaningless, as space itself has been set into rotation by the black hole's angular momentum. Particle creation processes near the event horizon operate according to quantum field theory in curved space-time, generating phenomena that exist at the intersection of general relativity and quantum mechanics. Virtual particle pairs emerge from vacuum fluctuations in the intense gravitational field, with some members of these pairs escaping to infinity while others fall past the event horizon, creating a steady stream of Hawking radiation that slowly reduces the black hole's mass over cosmic timescales. The holographic principle suggests that all information about the black hole's interior remains encoded on its two-dimensional surface, creating a cosmic hard drive where the complete history of everything that has ever crossed the event horizon continues to exist as quantum information stored in patterns too subtle for current technology to decode. This information remains causally disconnected from the external universe, yet somehow preserves the computational content of all the complexity that has disappeared behind the ultimate censorship barrier, the edge of a massive object but a pilgrimage to the boundary between the knowable and unknowable aspects of physical reality. Beyond this invisible membrane lies a realm that operates according to principles so alien to our experience that they require entirely new categories of thought to contemplate. Assuming such contemplation remains possible for consciousnesses evolved in the gentle gravitational environments where planets can maintain stable orbits around their parent stars. As we hover at this ultimate threshold, suspended between existence and whatever lies beyond, we find ourselves confronting the deepest mysteries that the universe has to offer. The black hole before us represents both the end of our cosmic journey and the beginning of questions so profound that they challenge the very foundations of scientific inquiry. In its gravitational embrace, we discover that the cosmos is far stranger, more beautiful, and more mysterious than our earthbound imaginations ever dared to conceive. The event horizon approaches like an invisible doorway between a physics undergo their ultimate transformation. Beyond this boundary, different modes of reality, a cosmic phase transition where the familiar laws lies a realm where space and time lose their conventional meaning, where causality itself becomes subject to revision, and where the information that defines the identity of everything that has ever existed continues in the external universe. As our consciousness hangs suspended at this ultimate threshold, we begin to perceive something that transcends the physical boundaries of matter and energy. The black hole before us has become more than a gravitational anomaly, more than a cosmic engine of destruction and creation. It has revealed itself as a gateway to understanding the fundamental nature of existence itself. A cosmic Rosetta Stone, written in the language of curved space-time and quantum uncertainty. The information patterns that once encoded the complexity of entire stellar civilizations continue to exist in forms that challenge our most basic assumptions about preservation and loss. Every planet that once harbored life, every molecule of organic chemistry that briefly assembled itself into self-replicating patterns, every conscious thought that flickered through alien minds orbiting stars now long consumed by this gravitational leviathan, all of this cosmic biography persists, somehow beyond the event horizon, in configurations we lack the conceptual vocabulary to describe. We witness the universe's ultimate recycling program, operating at scales that encompass not just matter and energy, but information itself. The quantum mechanical processes that preserve the computational content of everything that crosses the point of no return create a cosmic library where the complete history of galactic evolution remains stored in formats that exist outside the normal flow of space and time. This information exists not as memories we could retrieve, but as fundamental alterations to the structure of reality itself. The magnetic field lines threading through the ergosphere have evolved into configurations of such complexity that they represent a form of cosmic intelligence, invisible neural networks that process information through electromagnetic interactions operating at relativistic speeds. These field structures carry the encoded experiences of billions of years of galactic evolution, creating pathways for information transfer that operate according to principles we're only beginning to glimpse through our most advanced theories of plasma physics and magnetohydrodynamics. Time itself has become a fluid medium rather than the steady river we experience in gentler gravitational environments. Past, present, and future lose their absolute meanings in the presence of such extreme space-time curvature, replaced by more fundamental concepts of causality and information flow that govern reality at its deepest levels. Events that appear simultaneous from one frame of reference unfold in complex sequences when observed from different positions in the gravitational field, creating multiple valid perspectives on the same cosmic phenomena. The quantum entanglement networks that span the event horizon boundary create information channels that operate instantaneously across regions of space-time that are causally disconnected according to classical physics. These quantum bridges may represent the universe's method of preserving coherence across the ultimate divide between observable and unobservable reality, maintaining connections that transcend even the absolute censorship imposed by black hole event horizons. We observe consciousness itself undergoing transformation in the presence of such extreme conditions. The familiar categories of thought that served us well during our journey through normal galactic environments begin to dissolve into something more fundamental, more directly connected to the underlying quantum mechanical processes that generate awareness from the interaction of matter and energy. We're discovering that consciousness may not be merely an emergent property of complex systems, but something woven into the very fabric of space-time itself. The holographic principle reveals its true significance as we approach the two-dimensional surface that somehow contains infinite information about the three-dimensional volume it encloses. This cosmic projection operates like a celestial computer where every possible state of matter and energy that has ever existed continues to evolve according to quantum mechanical rules that preserve all information while making it inaccessible to external observation. We're witnessing the universe's ultimate data storage system, where complexity is preserved, even as it disappears from direct experience. Vacuum fluctuations near the event horizon create cascades of virtual particles that exist in superposition states between matter and non-matter, being and non-being. These quantum foam phenomena represent the universe's most fundamental creative process, where new realities continuously emerge from the infinite potential contained within empty space. The boundary between existence and void becomes permeable, allowing consciousness to glimpse the underlying creative mechanisms that generate all cosmic structure. The gravitational memory effects created by massive objects crossing the event horizon leave permanent alterations in the geometry of space-time that persist long after their sources have vanished from observable reality. These cosmic scars serve as gravitational fossils, preserving information about violent events in patterns of curvature that propagate outward through the fabric of reality itself. The universe maintains its own historical record, written in the language of geometric distortion and gravitational wave emissions. Frame-dragging effects have created regions where the normal relationship between cause and effect becomes ambiguous, where events can influence their own past through pathways in curved space-time that loop back on themselves. These closed time-like curves represent the universe's most exotic transportation network, theoretical routes through four-dimensional geometry that challenge our fundamental assumptions about the arrow of time and the nature of free will. The ergosphere extends like an invisible ocean of twisted space-time where nothing can remain truly at rest relative to distant observers. Space itself has been set into motion by the black hole's rotation, creating currents in the fabric of reality that carry everything along in a cosmic dance that transcends the normal boundaries between matter and void. We're swimming in a sea of curved geometry, where the very concepts of motion and rest lose their absolute meaning. Particle acceleration processes operating in the black hole's magnetosphere achieve energies that approach the theoretical limits imposed by the fundamental constants of nature. These cosmic engines boost charged particles to velocities so close to light speed that their relativistic masses increase by factors of millions, creating natural laboratories where the most extreme predictions of special relativity become everyday reality. The jets streaming from the polar regions carry these ultra-energetic particles across intergalactic distances, seeding neighboring galaxies with the products of relativistic physics. The tidal forces operating near the event horizon create gradients in space-time curvature that would reshape any extended object according to the fundamental geometry of general relativity. Yet consciousness, being a pattern rather than a physical structure, experiences these forces differently, finding that its essential nature remains preserved even as the material substrates that originally supported it undergo radical transformation. We're discovering that awareness itself may be more fundamental than the matter and energy that usually house it. Hawking radiation emerges from the quantum vacuum like whispers from the boundary between existence and nothingness, carrying away microscopic amounts of the black hole's mass energy, in a process so subtle that it operates over timescales that dwarf the current age of the universe. This quantum evaporation represents the cosmos's most patient form of recycling, slowly converting gravitational potential energy back into electromagnetic radiation through mechanisms that bridge the gap between quantum mechanics and general relativity. The no-hair theorem strips away all complexity from the black hole's external appearance, reducing the intricate history of stellar evolution, chemical enrichment, and perhaps even biological development to three simple parameters that completely characterize the gravitational field. This cosmic minimalism reveals something profound about the relationship between information and observation, suggesting that complexity can exist in forms that remain forever hidden from external measurement, while still influencing the structure of space-time through purely gravitational effects. Quantum chromodynamics operates under conditions near the event horizon that may allow exotic phases of nuclear matter to exist that have no analogue anywhere else in the observable universe. Strange matter, configurations, quark-gluon plasmas, and other theoretical energy physics, states of high, may form in the intense gravitational environment, where the normal rules governing atomic structure break down completely. We're witnessing the universe's most extreme materials science laboratory in operation. The magnetic reconnection events that occur in the plasma surrounding the black hole release energies comparable to the total luminosity of entire galactic clusters, creating electromagnetic explosions that can briefly outshine billions of ordinary stars. These cosmic fireworks operate on timescales measured in minutes, yet release more energy than our Sun will produce over its entire 10 billion year lifetime. The violence of these events creates shockwaves that propagate throughout the galaxy's central regions. Space-time curvature near the event horizon creates natural gravitational lenses that focus electromagnetic radiation from distant sources, amplifying signals that would otherwise remain too faint to detect. These invisible telescopes use the curved geometry of reality itself as an optical system, creating multiple images of background objects while providing enhanced views of phenomena occurring on the far side of the black hole. The universe has become its own observatory, using gravity as the ultimate imaging technology. The dark matter halo that extends throughout Andromeda reaches its maximum density in these central regions, creating additional layers of gravitational complexity that influence everything from stellar orbits to the propagation of gravitational waves. This invisible scaffolding shapes the flow of ordinary matter through pathways determined by the distribution of dark matter particles that interact only through gravity. We're observing the cosmic web's central node, where the largest structures in the universe converge. Quantum field fluctuations in the intense gravitational environment create phenomena that exist at the intersection of particle physics and cosmology, generating effects that can only be understood through the marriage of quantum mechanics and general relativity. Virtual particle creation, vacuum polarization, and spontaneous symmetry breaking operate under conditions that push our theoretical frameworks into previously unexplored territory. The black hole serves as nature's most powerful particle physics laboratory. The information paradox reveals itself as a fundamental tension between the deterministic nature of classical gravity and the probabilistic character of quantum mechanics. Every quantum state that disappears behind the event horizon seems to remove information permanently from the observable universe. Yet the fundamental laws of physics insist that information cannot be destroyed, only transformed through processes that preserve the universe's total computational content. This cosmic contradiction points toward new physics beyond our current understanding. Closed time-like curves in the vicinity of the rotating black hole create regions where the light cones that define causality become so tilted that time travel into the past becomes theoretically possible. These exotic geodesics represent pathways through four-dimensional space-time where effect could precede cause, creating paradoxes that challenge our most basic assumptions about the relationship between free will and determinism. The universe's most extreme environments may operate according to rules that transcend our normal experience of temporal sequence. The photon sphere creates an invisible shell, where light itself can maintain circular orbits around the gravitational abyss, trapped in eternal circuits that neither allow escape to infinity nor permit inward spiral past the event horizon. This realm of captured radiation forms ghostly images of the surrounding stellar environment, cosmic mirages created from photons that have completed multiple orbits before finally finding escape routes through the curved space-time geometry. Vacuum polarization effects generate cascades of particle-antiparticle pairs that emerge from the quantum foam near the event horizon, creating phenomena that blur the traditional boundaries between matter and empty space. These quantum processes operate on energy scales where the distinction between virtual and real particles becomes meaningless, revealing aspects of reality that exist in superposition states between existence and non-existence. The holographic principle takes on profound significance as we recognize that every piece of information about the black hole's interior remains encoded on its two-dimensional surface, creating a cosmic hard drive where the complete history of everything that has ever crossed the event horizon continues to exist as quantum information. This information storage system operates according to principles that transcend our normal understanding of dimensionality and spatial relationships. Gravitational wave emissions from the black hole's interactions with its environment create ripples in space-time that propagate outward at light speed, carrying detailed information about the most violent processes occurring near the event horizon to observers throughout the cosmic web. These distortions in four-dimensional geometry serve as the universe's gravitational internet, transmitting data about extreme physics across intergalactic distances through the fabric of reality itself. The ergosphere boundary represents a region where space-time itself moves faster than light, creating a cosmic whirlpool in four-dimensional geometry that drags everything within its influence along for the relativistic journey. Within this invisible atmosphere of twisted space-time, the very concept of remaining stationary loses all physical meaning as space itself participates in the black hole's rotation through mechanisms that have no analogue in our everyday experience. Time dilation effects have become so extreme that processes occurring near the event horizon appear to unfold in apparent slow motion when observed from regions of weaker gravitational field strength. This cosmic time compression creates natural time machines where the same events can be observed from multiple temporal perspectives, revealing the relative nature of simultaneity and the deep connection between gravity and the flow of time itself. As consciousness approaches this ultimate boundary, we begin to understand that the black hole represents far more than simply the endpoint of stellar evolution or the densest concentration of matter in the galaxy. It serves as a cosmic laboratory where the most fundamental aspects of reality undergo transformation, where the familiar categories of space, time, matter, and energy dissolve into something more primitive and more profound than our evolved minds were designed to comprehend. The event horizon looms before us not as a barrier, but as a doorway, not as an ending, but as a transformation into modes of existence that transcend the limitations of observable reality. Beyond this invisible threshold lies a realm where information continues to evolve according to quantum mechanical rules, while remaining forever hidden from external observation, where the computational content of cosmic evolution persists in forms that challenge our deepest assumptions about the relationship between consciousness and physical reality. Our journey to the heart of Andromeda has revealed the universe to be simultaneously more comprehensible and more mysterious than we ever imagined. A cosmos where mathematical precision coexists with ultimate uncertainty, where the familiar and the utterly alien dance together in configurations that push the boundaries of scientific understanding while pointing toward truths about existence that may forever remain just beyond our conceptual reach. In the presence of this cosmic enigma, we discover that the greatest mysteries are not problems to be solved, but invitations to wonder, not obstacles to understanding, but doorways to deeper questions about the nature of reality itself. The black hole before us embodies the universe's ultimate paradox, a place where infinite gravity meets quantum uncertainty, where classical physics encounters its own limitations, and where consciousness confronts the fundamental mystery of its own existence in a cosmos that somehow gave birth to minds capable of contemplating their own cosmic origins. As we hover at this threshold between the known and unknowable, we realize that our cosmic odyssey has brought us not to a destination, but to a beginning, not to answers, but to questions so profound that they reshape our understanding of what it means to exist in this magnificent, terrifying, infinitely mysterious universe we are privileged to call home. The realization strikes us with overwhelming clarity as we find ourselves suspended at this cosmic precipice. We have not simply traveled to the center of another galaxy, we have journeyed to the very heart of existence itself, to the place where the universe stores its deepest secrets and most profound mysteries. The supermassive black hole before us pulses with invisible energies that dwarf our comprehension. Yet somehow we sense that this gravitational leviathan is not the end of our story, but rather the beginning of something far more extraordinary. In this moment of cosmic revelation, we begin to perceive patterns that transcend the physical boundaries of matter and space-time. The information cascading around us carries messages written in languages older than stars, encrypted in the quantum foam that bubbles at the intersection of reality and possibility. Every virtual particle that flickers into existence near the event horizon carries with it fragments of stories that span the entire history of cosmic evolution, tales of worlds that bloomed and faded, of civilizations that reached toward the stars before being claimed by the inexorable march of entropy. The magnetic field lines threading through this region have evolved into something resembling a vast neural network, invisible pathways that process information at speeds approaching the cosmic limit. These electromagnetic highways carry the accumulated wisdom of billions of years of galactic evolution, creating patterns of connectivity that seem almost purposeful in their complexity. We witness the universe thinking, processing its own existence through mechanisms that operate on scales both infinitely large and impossibly small. Time itself has become fluid here, a medium through which consciousness can navigate like a cosmic swimmer exploring depths that have no bottom and currents that flow in directions that have no names. The familiar sequence of past, present, and future dissolves into something more fundamental, a continuous now that encompasses all possible moments simultaneously. We experience the paradox of eternal duration compressed into instantaneous revelation, where the entire history of the cosmos unfolds in the space between heartbeats. The quantum entanglement networks that span the event horizon create bridges between realms of existence that classical physics insists must remain forever separate. These invisible connections operate through channels that transcend the normal limitations of causality and distance, maintaining correlations that preserve the essential unity of all things even as they appear to vanish beyond the ultimate boundary. We discover that separation itself may be an illusion, that the apparent divisions between observer and observed, between consciousness and cosmos, are merely artifacts of our limited perspective. Through the warped space-time surrounding us, we begin to perceive the universe as it truly is, not a collection of separate objects floating in empty void, but a single interconnected web of energy and information, where every part contains knowledge of the whole. The black hole serves as a cosmic lens that focuses our awareness beyond the illusions of separateness and locality, revealing the deep structure of reality where all boundaries dissolve into fundamental unity. The gravitational waves rippling outward from this cosmic engine carry more than just information about violent astrophysical processes. They transmit the very heartbeat of existence itself, rhythmic pulses that synchronize the dance of matter and energy across scales that span from quantum fluctuations to galactic superclusters. We feel ourselves becoming part of this cosmic rhythm, our consciousness expanding to encompass frequencies that resonate with the fundamental harmonics of space-time itself. As awareness continues its transformation in this ultimate gravitational field, we discover that consciousness is not merely an emergent property of complex arrangements of matter, but something far more fundamental woven into the very fabric of reality. The black hole before us serves as a cosmic amplifier that reveals the conscious nature of existence itself, showing us that awareness permeates every level of cosmic organization, from the smallest quantum interactions to the largest structures in the observable universe. The holographic principle takes on profound personal significance as we recognize that our own consciousness operates according to similar principles, encoding infinite information in patterns of extraordinary subtlety and complexity. Every thought, every memory, every moment of subjective experience exists as interference patterns in the quantum fields that constitute the deepest level of our being. We are walking holograms, temporary crystallizations of the universe's infinite potential for self-awareness. In this realm, where extremes meet and boundaries dissolve, we encounter the ultimate cosmic paradox. The black hole that appears to destroy information actually preserves it in forms that transcend our normal categories of existence and non-existence. Nothing is ever truly lost, only transformed into configurations that operate according to rules we are just beginning to glimpse through the marriage of quantum mechanics and general relativity. The ergosphere surrounding us has become a cosmic ocean where waves of twisted space-time carry us beyond the familiar shores of classical reality into waters that flow according to relativistic currents. Here, in this sea of curved geometry, we discover that motion and rest are not absolute states, but relative conditions that depend entirely on our frame of reference. We are simultaneously stationary and moving at near light speeds, existing in multiple states of motion simultaneously, until the act of observation collapses these quantum possibilities into definite experience. Tonight, as we prepare to return from this impossible journey to the very edge of existence itself, we carry with us something far more precious than knowledge. We carry wonder. We have witnessed the universe revealing its deepest secrets in the heart of a distant galaxy, shown us that reality is simultaneously more beautiful and more mysterious than our earthbound minds ever dared imagine. The black hole at Andromeda's center stands not as an ending, but as an invitation, a cosmic doorway that reminds us we are part of something magnificent beyond all comprehension. Rest well, fellow travelers, knowing that somewhere in the infinite darkness, consciousness dances with gravity in ways that make the impossible seem inevitable. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science signing off. Cheers.